Okay, good morning pre-calc and welcome to our new unit. So we're going to be checking out systems of equations and matrices in this unit, and this is what we'll be doing until the end of the year if we stay at home here. Um, what I want to start us off on is just give you some information about where to find all the PDFs. They should have been uploaded on Google Classroom at 8 a.m. today, so you can check them out. And if you want to print them out, the one called Student Notes is the one that you would be able to print out and follow along with. We're going to continue with my office hours being from 11 a.m. to 1 p.m. Just keep that in mind. Okay, so let's jump right into it. We're going to start with pretty much a pretty basic review of just two variable system equations. This is good old stuff from Algebra 1 here. And we're going to actually skip the graphing just because I know you guys don't have the packets, or not everyone does. So we're going to go ahead and jump to some two variable system equations using the substitution method and the elimination method. So remember, system equations, when we have two or more equations and we want to figure out where they intersect pretty much. Okay? And the first way that we can solve these guys is by using the substitution method, which is where we solve for one of our variables, and then once we do that, we substitute the expression into the other equation so that we only have one variable to deal with. And then we solve for that variable and we use substitution to figure out our final answer. So when we're doing that, a thing to keep an eye on is look for variables that don't have a coefficient out in front other than 1. Like for example, this 1x minus 5y equals 13. I'm going to try and solve for x because that's going to be a little bit easier. So I'm going to take that x minus 5y equals 13 and I'm going to add 5y on both sides. And I get something like that. Okay, so I just did step 1. I solved either equation for one of the variables. So I solved for x in this guy. And then what I like to do is I actually like to box this guy up. Because what this equation is actually telling me is that x is equivalent to 5y plus 13. These guys are equal to the same thing. So in my other equation where it says x, I could actually replace that with 5y plus 13. So I'm going to rewrite that equation. I'm going to do negative 7. Instead of x, I'm going to write the 5y plus 13. And then all I have to do now, because I only have one variable, is just solve this equation, which is pretty easy. I'm going to distribute the negative 7. I believe that's 91. And then I'm going to solve negative 35y and 8y, that's negative 27y. I'm going to add 91 both sides. So I got negative 27y equals 81. And divide by negative 27. It looks like I get a y value of negative 3. But whenever we're solving these systems, we actually want to find an x and a y. We want to find a coordinate of where these guys would intersect. So we found the y value. To find the x value, just go back to what you boxed. In this case, it's 5y plus 13. And if I just plug negative 3 in for y, it will tell me what x is, right? So I'm going to do x equals 5 times negative 3 plus 13. That's negative 2. So my answer is going to be negative 2 comma negative 3. And we're all good. Okay, so we're going to jump over to number 7. We'll show you one more of these guys. And in this guy, you'll notice that we don't have any coefficient. That is 1. So here we just kind of have to choose. We're probably going to get some nastier stuff going on, but that's all right. So I'm going to choose, how about I choose y for this top equation. So I'm going to go ahead and take 3x minus 2y equals 30, and I'm going to solve for y. So I'm going to subtract 3x. I got negative 2y equals negative 3x plus 30. I'm going to divide by negative 2. Got to divide everything. So I got y equals, that's going to be, I'm going to write it as a decimal, so that's 1.5x minus 15, right? So this is what y is equivalent to, so in my other equation over here, I can just go ahead and substitute that in. So I got 7x plus 5, instead of y, we're going to write 1.5x minus 15, right? And then we're going to equals negative 17. So I'm going to distribute the 5. that's going to be 7.5x minus 15 times 5 is 75, I believe. And then we just solve the equation. So that's going to be 14.5x minus 75 equals negative 17. I'm going to add 75 to both sides. And I got 14.5x equals negative 17 plus 75. Is that 58, I believe? Hopefully I'm doing that right. And I'm going to divide by 14.5. And that should give us something like 4, I think. Right, so we get an x value of 4. Right? And then just like in our previous one, we got to make sure that we find our y value, the other missing guy. So I'm going to go back to this box and I'm going to say y equals 1.5. I know x is 4 now, so I just plug that in. 1.5 times 4 is 6, and that gives us negative 9. So it looks like our answer is 4 comma negative 9. That is where those two lines would intersect. Okay, so the other method that we're going to check out is our elimination method. So we'll do 2 problems from that as well. So if you just flip this guy over, you'll see our elimination method. Okay, so the first thing we do with the elimination method is align our equations. That means our x's, our y's, our equal signs, our constants, they all have to be on top of each other. Okay, and then we want to multiply one or both equations by a number so that one of our variables has the same coefficient. Okay? Then we want to subtract the equations to eliminate a variable, and then use substitution to find that other missing variable here. So let's check out number 9 to start off. And you'll notice on number 9 we have all our variables aligned. The x's over the x's, y's over y's equals constants. But we don't have what we need in terms of our variables. So what I'm going to do is to get my y variables to be the same, I'm going to multiply this entire equation by 6. And what that'll make it look like now is 18x plus 6y equals negative 150. And now what you'll notice is we have 6y and negative 6y right on top of each other. So we can actually add these equations together and those guys should eliminate, right? So I'm going to do 18x plus negative 7x, that's 11x. These guys, like I said, are going to cancel. And when I add negative 150 and 62, I think I get negative 88. And then, see, all I have to do now to get what x is equal to is divide by 11. And it looks like I get negative 8. And then to figure out what our y value is, we just go back to either of our original equations. I'm going to use the top one, and I'm going to put a negative 8 in where it says x. And then all I have to do is just solve for y. So I'm going to add 24, and it looks like I get y equals negative 1. So my answer here is negative 8 comma negative 1. Okay, so sometimes you might have to rearrange an equation. Like if you take a look at number 12, see how our variables aren't aligned? So what I'm going to go ahead and do is on this top guy, I'm going to kind of do some work in my head. I'm going to subtract 9x on both sides, and I'm also going to subtract 6y on both sides. And that's going to give me something like this. I'm going to have negative 9x equals 39 minus 6y. So these guys, I kind of switched, but remember I had to subtract to get them on either side. And if I rewrite my bottom equation, see how everything's lined up now? And an equation like this, I still have to make sure that one of my variables has the same coefficient or the opposite coefficient. Either one works. So I'm going to multiply this bottom equation by 3. So now let's rewrite everything again. And I'm going to have this new bottom equation be negative 9x equals 39 minus 6y. Okay? And you might have already noticed this, but we actually have everything. Okay, when we subtract these guys from each other, negative 9x minus negative 9x cancels, right? 39 minus 39, 0. Negative 6y minus negative 6y, also 0. So this guy just ends up being 0 equals 0. And just like with an equation, if we get a situation that's a true statement, it means we have an infinite amount of solutions. You could either write that or infinitely many solutions. Right? And then I just want to show you one application problem. These guys, you have the option of using either method to solve, but what I want to make sure you can do is just set it up correctly. So if you check out this one, we have Jasmine has 35 coins in her wallet, all nickels and quarters. If the total value of the coins is 4.35, how many nickels and how many quarters does she have? Right? So first off, I'm going to say X equals my nickels and Y equals my quarters. And I have to set up two equations. I know that she has 35 coins total, so I know if I take my X and I add my Y, it should equal 35. If I take all my nickels and all my quarters, I should have 35 coins total. She also gave us the total value of the coins, so that means for every nickel we have, it's going to be a value of 0.05, right? For every quarter, it's going to be 0.25. And it ended up equaling $4.35. So there's my two equations, and then you just kind of solve them however you'd like, either substitution or elimination. Okay, I'm going to go ahead and do, let's do elimination. I'm going to multiply this bottom by 4 because that will give this 0.25y, it'll make it 1y, and we'll be able to cancel those guys out. So my top equation is staying the same. My bottom equation, I got, now it's going to be 0.20x plus 1y equals, this is going to end up being 16, what's that, $17.40, I hope. I might double check that. Where's my phone at? Oh, it's taking the video. We're going to just have faith in Whitman. Right? And then I'm just going to subtract the equations from each other. So x minus 0.2 is going to be 0.8x. These guys are going to cancel. And then 35 minus $17.40 is going to be $17.60. And then finish off by dividing by 0.8. And let's see what we get here. So we're going to do 17.6 divided by 0.8. Looks like we get 22 for our number of nickels. 22 nickels. And then all we have to do to figure out our quarters is go to either top equation. I'm going to use the top one, x plus y equals 35, and then subtract 22, and we get something like, what's that going to be, 13? So we got 13 quarters. So this one you don't have to write. With word problems, you don't have to write in an ordered pair. You just want to make sure that you label them correctly. So 22 nickels and 13 quarters. Okay, so hopefully you guys remember that a bit. Okay, there's a thing to note here. There's a couple like probably headwind ones that are a little weird where you just gotta remember that a headwind is against the wind. So headwind is your actual speed minus the wind speed. And a tailwind is something that helps you. So if you do see that in any word problem that I'm asking you to do, just make sure you keep that in mind. So for homework, I want you to do numbers 4 through 12 evens. So just numbers 4 through 12 evens. It's only like 6 problems or something like that. All right. Remember, I'm available 11 to 1 if you need help.